think it is. I don't know. We don't look at the book very often.
You have to teach.
I don't, yeah, but we don't look at the
Yeah,
book
I
very often.
want to look at the school sheet too. It says what the homework is.
Yeah.
That's why I usually go by.
But I think it's 6.5, maybe. I don't know. Whatever. Zero factor property. And this is what your book calls it. I call it the zero product property. Why this book calls it the zero factor property, I don't know, but it does. What the zero factor property allows us to do is it allows us to solve quadratics and solve lots of things that are in factored form already. What essentially it says is if you have a times b, then either a times b equals 0. Then either a is equal to 0, b is equal to 0, or both a and b are equal to 0. Okay, it's called the zero product property. And a and b are just variables or sets of variables. X, y, 3x plus 2 times 2x plus 4, whatever. But we call it the zero factor property or the zero product property, depending on which textbook you're looking at. So that first one's an example of something that's already in factored form. It's a quadratic. If we multiplied it out, I think it's 2x squared minus 6x minus 18, something like that. That's not right. 2x squared plus 9x minus 18 equals 0, whatever. It's factored for you already. So what the zero product property says that if I want to figure out what are the solutions to this equation, the zero product property states that one of two things or both have to happen. Either x plus 6 is equal to 0, or 2x minus 3 is equal to 0, or both of them are 0. Now we've just got equations that we have to solve. So you can think about it in your head. What plus 6 is 0? Negative 6. So we get x is equal to negative 6. So you can just think about it in your head. Or, as you've solved equations in the past, subtract 6 from both sides. You get x is equal to negative 6. So negative 6 is one of the solutions that makes that equation true. So if I were to plug negative 6 in, negative 6 plus 6 is 0. If I plug it into here, that's like negative 15. 0 times negative 15 is 0, so it makes it a true statement. Okay? Or we solve the other one. This one's not so easy to solve in your head. Well, it is. Algebraically, add 3 to both sides. That leaves me with 2x equals 3. Divide by 2. There's my other solution, is 3/2. So if my x is either of those or both of those, then I have a true statement. That's what the zero product property says, or the zero factor property says. That you set each individual piece equal to 0 and you solve. Okay, so we have this second one. Well, that was cool. Weird. So we have this second one that says x plus x times x plus x3. Start over. X times 3x plus 8 equals 0. So it's saying we're taking x times this quantity. So this one tends to be a little bit confusing for the zero product property for people, but it doesn't need to be. The zero product property says that either x is equal to 0, so I set the front part equal to 0, or the second part, 3x plus 8, is equal to 0. People always forget this one. Okay, if you're multiplying x, you're distributing that in, you still have to then set it equal to 0. First one's already solved. We get x is equal to 0. That's the solution. Subtract 8. 3x equals negative 8. Be lazy. There's your second solution. Okay, if I plug either of those in, I would get a true statement. So those first two examples were problems that we already had in factored form. They were factored for you. If it's factored for you, just set each part equal to 0. And it can be 3. You could have 2x plus 3 times 3x plus 4 times 8x plus 7 times 274x squared minus 3. Just set each of those pieces equal to 0. It doesn't have to be 2. It can be 3. It can be 4. It can be as many as we want. Well, what happens if it's not factored for us? And that's the next type that we're going to look for. Well, we've been working on factoring the last few days, and you don't need to write this down. I'll post the notes inside of Schoology for you if you need them. But we talked about these steps these last few days. Step 1, write it in standard form. Step 2, factor. Then use the steps we did for factoring. Take out any GCFs, look for differences of squares, look for sums of cubes, look for all of those things. And then you're going to use the zero factor property to find your solutions. And then you check it. We're not going to worry about checking it so much. We're going to assume that we factored everything correctly and everything is right. But no, you can check these and see if you got it right or not. Okay? So let's look at several of examples of these. So now it's not in factored form, but we've got an equal sign. The last 2 days, we haven't had equal sign, so we've just had to factor. Now we see an equal sign, and anytime you see an equal sign, it means you need to solve. So we have to solve this. So step 1 is to put it in standard form. So standard form, recall, is ax squared plus bx plus c equals 0. So I've got the 2 on the right-hand side. I need to make that side equal to 0, so I'm going to go ahead and subtract 2 from both sides. So now I'm sitting with 2x squared plus 3x minus 2 equals 0. Now it's in standard form. Factoring says that the next thing I look for is a GCF. Numbers are 2 and 3. GCF is just 1. There's not x's in all of them. There's not a GCF. So trinomial means try the x method to see if it works. What goes on the top? -4. What am I dividing by? 2. Because my a value is 2, so I'm dividing by 2. What goes on the bottom? 3. So I need two numbers that multiply together to be -4, that add together to be 3, because one of these is negative, one is positive. So positive 4, -3, -1.
Yep.
So then in factored form, that fraction is reduced. So remember, the 2 goes out in front of the variable -1. 4 divided by 2 is 2, so that's just x plus 2. Now it equals 0. Now it looks a lot like what we just did. It's in factored form. So now we use the zero factor property. So 2x minus 1 equals 0, or x plus 2 equals 0. Add 1. Get 2x equals 1, divide by 2, you get an answer of 1/2. The other one, what plus 2? So there are your solutions. Here and here. What do you notice about what's in the x in accordance to what your solutions are?
If you just flip them, you get it.
They're the opposites, or you opposites. Don't use the flip means
Well, I mean,
flip. Yeah, I knew what you meant, but just be careful with the word flip. That would mean to me that would mean reciprocal.
yeah.
So opposites. We had -1/2 sitting over here. We had a solution of 1/2. We had 2 sitting right here. -2 was our solution, and that's what it is. Okay, your solutions are just the opposites of what you have right there. That's kind of why it works. Okay. So it's important that you understand what the question is. So if the question is just to solve, If the question is just to solve, do you really need to do this part? Nope. If the question is to solve, technically speaking, you don't even need to do that part because you have your solutions right there. If you're asked to factor, however, that's different. If you're asked to factor first, then you have to do that part. But if you're just asked for the solutions, it's the opposite of what's right there. Save yourself some time. Let's look at another one. 4z squared minus 20z equals 0. There's no c value in this one. That's okay. We don't need to put plus 0 there. First rule of factoring. Take out a GCF. What's the GCF for 4 and 20? 4. What's the GCF of z squared and z? So we're going to take a 4z out. If we take 4z squared divided by 4z, we're left with z. 20z divided by 4 is 5. Okay, now we're good to go. These are even easier. So 4z equals 0. So z equals 0. There's your first solution. Or z minus 5 equals 0. Z equals 5. So when you don't have the c value, it's nice. Just take out a GCF and move on. When you don't have that c value in there. Still using the zero factor property. Questions with that one? All right, next one. (3m squared minus 108 equals 0). Now there's no b value. Well, still follow the rules. It's subtraction. Is it a difference of squares right now? Do you know the square root of 3? You don't know the square root of 3. So we can't use difference of squares yet, so we have to look for a GCF. 3 goes into both of them, so I'm going to take a 3 out. If I take a 3 out of, if I take 3m squared divided by 3, I'm left with m squared. 108 divided by 3, 36. So we've got this. Now, because we're factoring, we need to look to see if this middle part can be factored. Do we know the square root of m squared? Yeah. Square root of m squared is m minus square root of 36. So that becomes m minus 6, m plus 6 equals 0. Is there another way to do this one? Yes. You could just say m squared minus 36 equals 0 and solve that, but we're factoring, so let's just factor. So now the 0, now we use the property. Because the 3 doesn't have a variable with it, we don't do anything with it. So all we're going to do is do the m minus 6 equals 0 and m plus 6 equals 0. And in all honesty, I mean, most of you can look at this and know your answers are 6 and negative 6. I mean, you're adding 6 to both sides, subtracting 6 from both sides, negative 6. So your answers are 6 and negative 6. You don't necessarily need to write all of that down if you can figure it out. Again, save your time. I mean, you've been seeing this stuff for a while. Some of you are pretty good at it already. Any questions with those 3? Got 2 more, I think, that we're going to look at. Oh, just 1 more. Oh. Write that down. There's something, I'm missing something. 6 right there. Okay, so now we've got this long, complicated thing that we have to solve. Okay. Now, what I can't do, I can't say 2x plus 1 equals 0 or x plus 1 equals 0. Can't do that because it doesn't equal 0. You can only use that property if it equals 0. Well, this doesn't equal 0. So we're going to have to kind of do some fun math with this type of problem. So we're going to go ahead and FOIL this out. So 2x times x is 2x squared. So that's the first. 2x times 1 is 2x. So that's outside. Inside, 1 times x is x. And last, 1 times 1 is 1. So I'm just going to combine the like terms. So that's 2x squared plus 3x plus 1. That's what the left-hand side looks like. Now I have to distribute and combine like terms on the right-hand side. 2 times 1 is 2. 2 times negative x is negative 2x plus 6. And again, I'm going to combine like terms. So 2 plus 6 is 8. So that's 8 minus 2x. Okay, this looks a lot better now. Just kind of made it, multiplied everything out and done the distributive properties and all of that. And combined like terms. Now if we're going to solve it, what do I have to set it equal to? 0. So I'm going to subtract 8 from both sides. And I'm going to add 2x to both sides. And I'm just lining them up to make my life easier. So that's 2x squared plus 5x minus 7 equals 0. So that huge mess now, which looked bad and looked ugly, is what math people like to do to you, is to make things look a lot harder than they need to be. Just use the skills that you know, and now we have it looking like one of the problems that we've already done today. Now we've got a quadratic, trinomial, so we're going to try the x method. I'll let you do this one. Much nicer walking to school today when it was 27 degrees as opposed to 3. Don't have any basketball players in your girls basketball players in your group. So I got beat by 6 last night. East is pretty good. 40 to 46, 40 to 48, something like that. Not bad. What is that?
At one point, both teams had 25.
Oh, wait. So my conversation with Marissa Shute yesterday was, shoot the ball. And the conversation became turnovers. If you're open, shoot it. Shoot it. Because you keep passing it around, what would you rather have, a missed shot or a turnover? A missed shot. Caitlin Clark averages 31 points a game for a reason. Because she shoots 30 times a game. Okay, she can shoot too, but still shoots 30 times a game. Marissa said she'd shoot it like 3 times, if that. Even if she was open, I ain't shooting. What goes on the top? Negative 14, divide by 2. Bottom number is 5. So factors of 14 that have a difference of 5. Negative 2 and 7. Go again, we're just asking for solutions. So this is negative 1. So one of my solutions is 1. This is 7 halves. My other solution is negative 7 halves. Okay. And again, if all I'm asking you for the solutions, that's all you got to do. If you want to put x minus 1 and 7x, nope. If If you want to put x minus 1 and 2x plus 7, have at it. But you don't need to. Okay? So that's what we're going to work on really the next 2 days. There's a few more problems, different types of problems that we'll look at tomorrow. Different types that I want to make sure that we go over prior to it. But it's essentially solving our same section tomorrow. For today, it's inside of Schoology. It's out of the book again. We're going to find that a lot more often now. You're going to do 4 through 26 even is what you have inside of the book. If you have questions, please make sure you ask. We are on PCR schedule today, so we are out of here at 10:11, assuming the bell rings.